In last class, we have completed the fourth chapter, data structure. So in previous classes, we have studied in detail about data structure topics. So yes, in last class, already we have completed this chapter, chapter number 4. So chapter, okay. So now in today's class, I will once again briefly revise this data structure chapter. So let us start. First, what is data structure? So in last class we have discussed data means anything like alphabets, numbers, digits, and structure means buildings. So data structure means these are the buildings to store data. So data is stored in memory using some data structures. So actually data structure is, in this chapter we have to study different methods and techniques of storing data in computer memory. So data structure means in this chapter we have to study the different methods and techniques for storing data in computer memory. So the proper definition for data structure is, so here you can see the definition is given. So data structure means this is a data structure is a specialized format for storing and organizing data in memory. So this is the proper definition you have to write in the examination. Data structure is a specialized format for storing and organizing data in memory. For understanding, I will tell you in simple words. So data structure is nothing but different methods and techniques for storing data. So where data is stored? Data is stored in computer memory using different techniques. So you have to study in this chapter. So in data structure, first we will begin with the types of data. So in data structure, there are two main types, primitive and non-primitive. So primitive data structure and non-primitive. So primitive means primary, basic data structure or natural, and non-primitive means this is derived from primitive data structure. So there are two basic types of data structure, primitive and non-primitive. So what is primitive? So primitive data structure is a data structure on which machine operates directly. Means on primitive data structure, without any complication, machine can easily work with primitive data structure. So what are the primitive data structure? Example is integer, float, character, pointer. So integer means 1, 2, 3 numbers, and float means decimal numbers 1.25, 5.8, like this decimal numbers, and character means alphabets A, B, C, D, and pointers means using star. So these 1, 2, 3 A, B, C, D and characters, all these things are the basic data structure called as primitive. So primitive data structure is a data structure on which machine can operate directly without any complication. Next, another type, non-primitive data structure. So what is non-primitive data structure? So non-primitive data structure is a complicated data structure derived from primitive data structure. So primitive data structure is a very simple data structure and non-primitive is a complicated data structure. And non-primitive data structure is derived from primitive data structure. Means non-primitive data structure is created using primitive data structure. So example of non-primitive data structure is, here you can see array, stack, queue, linked list, like this. Okay, now again there are two types of non-primitive data structure. So in non-primitive data structure, there are two types. One is linear data structure, another is non-linear data structure. So let us see first what is linear data structure. So linear data structure consists of homogeneous elements. Means linear means straight. So linear data structure is a data structure like a straight list, or homogeneous. Homogeneous means continuous elements of same type. Okay, so here examples of linear data structure are array, stack, queue, linked list. So these are the types of linear data structure. Then non-linear data structure. Non-linear means non-straight. They are not straight. So non-linear data structure. In non-linear data structure, a data item is connected to several other data items. Example is tree and graph. So here also in diagram you can see tree and graph. These are non-linear, non-straight, and these remaining 4 data structures are linear or straight. So in picture here you can also see. So this is data structure. In data structure there are 2 main types: primitive data structure and non-primitive data structure. So primitive data structure and non-primitive data structure, there are 2 basic types of data structure, main types. So what is primitive data structure? Primitive data structure is nothing but simple data structure which machine can easily work with. Primitive data structure example is integer. So example of primitive data structure is, or types of primitive data structure is integer. Integer means 1, 2, 3 numbers, and real numbers or real. Sometimes it is also called as float, real or float. So real or float data structure means decimal numbers 1.2, 1.3 like this. Next is character. Next is character data structure. Characters means ABCD. So ABCD like this. This data is called as character data. And Boolean. Boolean means true and false. So these are the types or example of primitive data structure. So in non-primitive data structure, again there are 2 types. First is linear data structure and another is non-linear data structure. So linear means straight and non-linear means not straight. So in linear data structure there are different types like arrays, linked list, stacks and queues. So these are the 4 types of data structure you have to study in this chapter under linear data structure. And non-linear data structure means trees and graphs. So just keep in mind this is the types of data structures. So first, data structure is mainly divided into 2 types: primitive and non-primitive. And again non-primitive data structure is divided into linear data structures and non-linear data structures. Okay, so now we will go in detail. Okay, now we will go in detail. So we have to study in detail non-linear data structures. So there are total 6 topics, linear and non-linear, we have to study in detail. So here I have given you notes. I have created this chart. This is called as quick review, means this is not the detailed notes, just this is for revision purpose, for quick review purpose. So here topic is there, name of structure, and here diagram, definition. So this is diagram, then this is definition, and types, basic operations, and uses or applications, and advantages and disadvantages. So this much we have to study about each type. Okay, so here first let us begin with array. So what is array? So I have given here the diagram of array, how the array looks like. So before the diagram, let us see the definition. So what is array? So array is a collection of homogeneous data elements with unique name. So array is a collection of homogeneous data elements with unique name. Homogeneous means same type, similar. So array is a group of same data items. So here this is the picture of the array. So array is like a continuous memory cells. So inside cell we can store the value A, B, C, D. This is the data like this. So every box is having some memory address 1000, 1001, 1002 like this, and this is the cell numbers 0, 1, 2, 3. So in array cell numbers starts with 0. So cell number is called as index or subscript value, and the first cell or first address of array is called as lower bound LB, and last cell is called as upper bound UB. So this is the diagram of array. So definition is completed. Then what is the, there are three types of arrays. First is one-dimensional array, second two-dimensional array, and multi-dimensional array, and basic operations. So basic operation is very important because in examination you will get question for 5 marks for basic operations. So there are 6 basic operations performed on arrays. So you have to write the list of these names of these basic operations, and you have to explain. For example, first basic operation of array is traversing. So traversing, what is traversing? Traversing is nothing but touching all the cells of the array or accessing all the cells of the array is called traversing. Next, it is very easy, so you can write in your own words. Then what is okay, second operation is insertion operation. What is insertion operation? So insertion means nothing but addition or adding. So insertion operation means we can add a value in array. Then deletion operation. So what is deletion operation? Deletion means removing or deleting the data. So deletion operation means removing or deleting the data from the array. Next, searching operation. So searching operation is nothing but finding a location of a particular value. Then sorting. What is sorting? So sorting is nothing but arranging the data in ascending order or descending order. Then merging. What is merging? So merging means converting two cells into a single cell is called merging. Then uses or applications of arrays. So where the arrays are used, uses of arrays. So it is used to implement other data structure. Means arrays is used to create other data structures like stack, queue, linked list, tree, graph, like this. Not tree graph, just stack, queue, and linked list. And second use, it is used to implement vectors and matrices. So in mathematics, you might have studied about vector and matrices. So array is used to implement vector and matrices. And third use, it is used to implement many databases. So database means nothing but collection of data. So array is used in creating databases. Next, advantages of arrays. So first, it is used to represent multiple data items of same type. Second, it is also used to represent matrices. So third type, it is used to implement other data structure like linked list, queues. So advantages are nothing but same as uses of array. Then disadvantage of arrays. What is the disadvantage? First one, so in advance exact size to be known, because array is of fixed size. So before using array, we should know what is the total numbers or value we are going to store. Next, array is a static structure. Third, it is of fixed size. And fourth, elements are stored in consecutive memory locations. Consecutive means continuous memory locations. So this is just, I am telling you the brief about data structure topics. Okay, so next, similar, stack. So what is stack? So stack is also a linear data structure. Linear means straight. So you can see in this diagram. So stack is almost same as arrays. Okay, stack is closed from 3 sides and it is open from only one side. So in stack, data is added and removed from the same side or same end. You can see in the picture from this upper side. Push means adding the data. Pop means removing the data or deleting the data. So push means insert or add, and pop means delete or remove. So okay, so here first we will see the definition. What is stack? So stack is an ordered collection of items in which elements may be added or deleted at the same end, called top of the stack. Means stack is a linear data structure where we can add or delete the data from one side only or from one end only. So this end is called as top. So this is the top end and this is the base end of the stack. Last cell of the stack is called as base and first cell of the stack is called as top. So in these cells we can store the data. So these cells are called as nodes. So node is the name given to the cells. So node is nothing but cells of this data structure. So node means cells. Okay, so here, okay, so in stack, important thing is we can add or delete the data from one side only, from the top of the stack. Next, what is the another name of stack? This is very important. Stack is also called as LIFO, means last in first out. It means in stack, whatever you store the data, last data you have inserted is deleted first. Last in first out means last data will be deleted first or it will go out first. Next, this is very important, basic operations on stack. So there are 6 basic operations of stack. First is just stack. So just stack means this operation creates a empty stack in the memory. Next, push operation. So push operation means it will insert or add the value in the top of the stack. Then pop. So pop means this pop operation removes or deletes the value from the stack. Next, peek. So peek operation checks what is the value stored in the top of the stack. Next, is empty. So is empty operation checks whether the stack is empty or not. Then size. So size operation checks how many or total values stored in stack. Size of the stack it will check. Then uses of stack. So what are the uses of stack? So it is used for backtracking. So already we have discussed in detail what is backtracking. Then it is used for undo operations, cancelling. And third, it is used in language processing applications like MS Word. Then it is used for conversion of decimal numbers into other number system. So already in first year you have studied conversion of numbers from decimal to binary, binary to decimal. So there stack is used. So this is a brief explanation about stack. Okay, next data structure is queue. So queue is also a type of linear data structure. Let us see the definition. So queue is a ordered collection of items in which element is inserted at one end, called rear, and removed from another end called front. Means queue is a linear data structure where data is inserted from one end and deleted from another end. So inserting end is called as rear and deleting end is called as front. So here in this picture you can see here this is the image picture of a queue data structure, and these are the cells. It is open from top and bottom. So top end is called as rear or back, and this means first cell of the queue is called as rear and last cell of the queue is called as front. So from rear we have to add the data. This is called NQ. NQ means adding data into the queue, and from bottom or front we can delete the data. So deleting is called as DQ, and these cells are called as nodes. So this is about queue. Next, queue is also called as FIFO. So another name of queue data structure is FIFO. FIFO means first in, first out. Means the data which comes first, it will go out first. So next, types of queues. So this is very important. Many times in examination question will come, what are the types of queue? So this is very simple. So there are 4 types of queue: simple queue, circular queue, priority queue, and DQ. So simple queue means, simple queue is nothing but normal queue. Simple queue is a type of queue where the data is inserted from one end and removed from another end. Next, circular queue. So in circular queue, what is circular queue? So circular queue is nothing but type of queue where the last end of the queue is connected to the first end. Means rear end is connected to front end. Means last and first cells are connected or linked. Hence it is called as circular queue. Then priority queue. What is priority queue? So actually in queue, data is added from first cell and removed from last cell, or data is added from one end and removed from another end. But in priority queue, data can be added or removed from any cell, not first and last. Here in priority queue we can delete or we can add the data from any cell. Then DQ. What is DQ? DQ full form is double-ended queue. So DQ. So in DQ we can insert or delete the data from both ends, from top or bottom or front and back. From both ends we can add and we can delete. So this is called DQ. Then basic operations on queue data structure. So there are 5 basic operations. First is queue. So queue means it will create a empty queue in the memory. Next operation is NQ. So NQ operation means it will add or insert a data value or a value or data item into the queue. Next, DQ. So DQ means it will delete or it will remove the data from queue. Next is empty. So this operation will check whether the queue is empty or not. Then size. So size operation will check the total values in queue. So this is about basic operations of queue. Okay, next here, uses of queue. So where the queue is used. So queue is used in simulation. Simulation means for training. Simulation means like for training of pilots how to fly the airplanes like this. Then queue is used for designing operating system, and queue is used in multi-programming systems. Queue is used in algorithms, and it is used in print server applications. So this is about queues. Then another data structure is linked list. So what is linked list? So linked list is also a type of linear data structure. Linked means connected. So here in this list all boxes are connected with a link. So in the diagram you can see. Okay, before diagram let us see the definition. So linked list. What is linked list? Linked list is a linear collection of data items called nodes. Means in linked list data items or cells are called as nodes, and every node has two fields. One for means two parts. In every cell there are two parts. One part for storing actual value and another for storing address of the next node. Next, what is the types of linked list? So here types are singly linked list, another type is doubly linked list, and third type is circular linked list. So first, what is singly linked list? So singly linked list is nothing but just a simple linked list. So singly linked list is a type of linked list which stores the data in the nodes, and every node has two parts for one part for storing information, another part for storing address. Then what is circular linked list? Okay, circular linked list is same as singly linked list, but here last node is connected to the first node, hence it will become a circle, hence the name given is circular linked list. So already we have studied all these things in detail in previous classes. So next, what is doubly linked list? So doubly linked list means every node has three parts. So in the diagram here you can see every cell or every node has three parts. So in first part is called back, center part is called info, and last right side part is called as forward. So center part is used to store actual information, and back means left side part is used to store the memory address of previous node, and forward or right side part, last part, is used to store the address of next node, hence it is called as doubly linked list. Next, what are the operations of linked list? First, creating means this operation will create a empty linked list in memory. Second operation is traversing is nothing but reading or touching or accessing all the nodes. Third operation is inserting. So inserting is nothing but adding a new node in the linked list. So insertion operation means inserting means here in linked list we can add a new data item or new node at the beginning or at the last or at the center of the linked list. Next, deleting. So deleting operation means it will delete a node from linked list. Next, searching operation will find the location of a particular data in the linked list. And last one is merging. So merging means combining two or more nodes into a single node. This is called as merging operation. Okay. Next data structure is tree. So now tree is an example of non-linear data structure. So non-linear means it is not straight, it is spread. So let us see the definition. Tree is a non-linear data structure consisting of nodes organized as hierarchy. Hierarchy means levels. So in this data structure, the data items or nodes are arranged integer, float, character, pointer. So anyone you have to write in the examination. Okay, next is so another here 3 marks question is give the memory representation for two-dimensional array using row major order. So already we have studied this topic in previous classes, so you have to write the answer. Then 5 marks question is, so here you have to write an algorithm for inserting an element into queue. So you have to write the algorithm. And another question of 5 marks is explain different operations performed on stack data structure. So on stack data structure, the basic operations you have to explain. So this is for 5 marks. So you have to explain these operations: stack, push, pop, peek, is empty, and size. So just we have discussed this. So like this question will come in the another question paper of I think March 2019. So here, what is primitive data structure? Explain different operations on primitive data structure. So just we have seen. So you have to write the definition of primitive data structure, and you have to write the operations: create, destroy, select, and update. 4 operations.